We know that as we grow, the hurdles will be more. Each time we get washed away, we bounce back to the shore. We know we lead the way, keeping odds at bay. See the sunrise tomorrow, inspire the world to follow.
Okay, today we are going to start our lecture number 3 on single phase induction motor. In our last 2 lecture classes, we have developed different conceptual aspects to explain the working of single phase induction motor, and we also described the constructional features of single phase induction motor, and we also explained how rotating magnetic field for more than one winding is produced, and as because single phase induction motor has a single winding, how the pulsating magnetic field is produced, whose magnitude change with the time but which remain stationary in space, that we have explained. And with the assistance of these theories, we have mentioned that the net torque production is 0. So single phase induction motor is not a self-starting motor, in contradiction with 3-phase induction motor. We have also mentioned that 2 different theories, one is called double revolving field theory, one is called double revolving field theory, and another one is cross field theory. These 2 theories explain the working of single phase induction motor. Each of these 2 theories has its own advantages, usefulness, and both these theories are lead to the more or less same conclusion. Now today we are only discuss the double revolving field theory. Okay, so we have also mentioned, when we have discussed in our lecture number 1 the working principle of single phase induction motor, that double revolving field theory is based on the idea that the air gap flux of single phase induction motor is consist of 2 oppositely rotating magnetic field in equal magnitudes and which rotates in synchronous speed, right? So that is the basics of double revolving field theory, and the resultant of these 2 oppositely rotating magnetic flux create the main field flux. Okay, so let's mathematically prove it first. Okay, so we know that phi m equals to sinusoidal flux, phi equals to phi m cos, it is rotating at omega rad per second, that means cos omega t means cos 2 pi ft. Okay, now from Euler's expression we know that cos of theta equals to e to the power j theta plus e to the power minus j theta divided by 2. So now we implement this theory in my expression. So it will become phi m by 2 e to the power j 2 pi ft plus e to the power minus j 2 pi ft. So this is again equals to phi m by 2 cos e to the power j 2 pi ft plus phi m by 2 e to the power minus 2 pi ft. So one we can take as phi f and one is phi b. So ultimately we get phi equals to phi f plus phi b, right? So now in this expression, this positive theta, one is negative theta. So one is rotating is clockwise direction and another one is rotating in anti-clockwise direction. So I have implemented this here. So the forward field is rotating in clockwise direction and the backward field is rotating in anti-clockwise direction. Okay. Now if we take different instances of time of this two differently rotating magnetic field which is rotated opposite to each other, one is clockwise direction and another one is anti-clockwise direction. So we will see basically a pulsating field is producing, which is combination of these two field, right? So now we have taken different instances A, B, C, D, E, different instances we have taken. So one field is A, what is rotating in clockwise direction, and another field is B, which is rotating in anti-clockwise direction. Both the magnitude are same, both are phi m by 2 and this is also phi m by 2. Now the resultant is phi m by 2 plus phi m by 2, that means 2 into phi m by 2. So it is nothing but phi m. So maximum value of the flux. So it will start from maximum value of the flux, right? Now after some time, both A and B, one is rotating in plus theta direction and another one is rotated in minus theta direction. So the total angle is theta. So the total angle is basically 2 theta. So this is theta, this is minus theta, the total angle is theta. So now the each of the flux is, so this is my phi m by 2, A is phi m by 2, and the resultant will be in this direction for A, and for B it is also same. So one is phi m by 2 cos theta by 2 and another one is phi m by 2 cos minus theta by 2, cos of minus theta theta, so cos theta by 2, right? So it will become 2 into phi m by 2 cos of theta by 2. So phi m cos theta by phi m cos theta by 2. So a different aspect is this. So that means we will, if we take the total angle, that is theta minus of minus theta, that is 2 theta. So, and each of this is half of this total angle, that means 2 theta by 2, that is theta. So, each of them is phi m by 2, phi m by 2, phi m by 2 cos theta. So, for A and for B also both are same, phi m by 2 cos theta. So, it is becoming phi m cos theta. So, are you getting my point? So, if we take the different angle, it will become phi m by cos theta by 2. Now, a different aspect is we have taken the total angle is 2 theta. So, each are 2 theta by 2, that is theta, and this is phi m by 2. So, the resultant is the component in the resultant direction is phi m by 2 cos theta, and for B it is also phi m by 2 cos theta. I am not considering these two angle sine. So, it will become 2 into phi m by cos theta, that is phi m by cos theta. So, now after a quarter cycle of rotation, now this is after a quarter cycle of rotation. So, this is A and this is B. So, the resultant is now 0. Now, after a half cycle, so from here this has started. So, after a half cycle means this position, it is again phi m minus phi m, because this is minus phi m by 2, this A equals to minus phi m by 2, and this B equals to, sorry, this is phi m by 2, this is minus, no, so sorry, this is also negative direction minus phi m by 2, this is also minus phi m by 2. So, the resultant is 2 into minus phi m by 2, that is equals to phi m. So, that is equals to phi m. And after 3/4 of the cycle, it shown in this position E, it is again becoming 0. So, if we plot the values of resultant flux from theta to 360 degree, then a curve similar to this is developing. Which is basically sinusoidal in nature, and that's why we can say that alternating flux can be resolved into two revolving fluxes, each of half the values of rotating speed of synchronous speed in opposite direction. Okay. So, basically this is the graph of the pulsatingly developed field. Now suppose we know the rotor is rotating at a speed of n rps, that means n by 60 rps, right? It is rotating speed of the rotor. So, the forward slip is suppose s. So, now what is my backward slip with respect to this forward slip, or rather respect to the rotor which is rotating at a speed of n rpm. Now, we know the rotor speed n equals to ns into 1 minus s. Ns equals to 1 minus s, right? So let me clear this page. So again we know ns equals to ns equals to ns equals to ns equals to sorry n equals to ns into 1 minus s, where this s equals to, from here also we get ns minus n by ns, that is equals to 1 minus n by ns. So s equals to this, right? Now backward rotating field, it is rotating in anti-clockwise direction, so now the speed will become n rpm minus n rpm. So the s is for backward field is ns minus minus of n by ns, so that is equals to ns plus n by ns equals to 1 plus n by ns, and we know from here that n by ns equals to 1 minus s. Now I put this value here, so it will become 1 plus 1 minus s, that is 2 minus s. So the slip of forward revolving field is s and the backward field is 2 minus s. So these are the two field developed, right? Now if we see here, so suppose different instances we have taken, right? Different instances we have taken. So in instant 1, so we can see from here that this is instant 1, so this is my backward field, this is my forward field, so resultant 1, this is 1 in this direction. Similarly for 2 it is the resultant, but the only difference is that the value of magnitude in 2 is a little bit lesser than this 1. Similarly for different position we will get again in negative direction, it is maximum reached, such as which is reached in positive direction from 0 to a positive value. So this is the resultant for this instant, this is the resultant for this instant, similarly this is the resultant for this instant. So let me describe it more properly by drawing this, right? So let me draw it. Okay, so this is my two field, one is rotating clockwise, one is rotating anti-clockwise, A and B. So the resultant is this, right? Resultant is this for position 1. Now again if we take different position 2, so again we will get the resultant in this direction with a lesser value. Similarly again for this we will get similar resultant. So if we see that from 0 it is getting the maximum value, again it is reached the maximum value, again it is becoming 0, again it is gaining some negative value, again it is reaching the negative maximum, again it is becoming 0 for the span of 0 to 360 degree, for the total span of 0 to 360 degree. So if we see, this is basically the nature of a sinusoid. Is 0 positive value sum, then maximum value, then again some negative values, negative maximum, again it becomes 0 in the span of 360 degree. So one thing we can conclude from here, we have also mentioned in our lecture class when we have described pulsating flux. So the magnitude is changing, but it is stationary in position. So if we take this position as T1, if we take this position as T1, this is T2, this is T3, 4, 5, 6, 7, 8 and so on. So in T1 it is 0, in T2 it is, if we use the parallelogram law, it is become 0.7075 m. T3 it is 5 m. T4 it is again similar to T2, then again it is 0. Suppose this instant is 5, so this is 6, this is 7, this is 8, this is 9. So in instant 5, T5 again it is 0, and then it so on in negative direction. T6 again it is minus 0.7075 m, which is similar to the position of T8. Again it in T9 position it is becoming 0. So this is the analytical description that a pulsating field can be considered of two differently rotating revolving field which is rotate opposite direction with respect to each other in synchronous speed, right? Now let me deduce the torque equation. Now we know for an induction motor we have seen that power, gross power PG equals to, or rather developed power PG equals to developed power PG equals to 1 minus S by S into I2 square R2, I2 square . So PG equals to 1 minus S by S I2 square R2, where N is the RPS, rotor speed, equals to Ns by 1 minus S. Now I put this value of N in the torque equation, and we know if this is the power, then torque Tg equals to 1 by 2 pi N into 1 minus S by S I2 square R2, I2 square R2. Tg equals to actually Pg by omega r, rotor speed in angular speed, and omega r equals to 2 pi n. So this is equals to 1 by 2 pi n 1 minus s by s I2 square R2. Now we put the value of n equals to ns minus ns into 1 minus s. So if we put the value here, 1 by 2 pi ns into 1 minus s into 1 minus s by s into I2 square R2. So 1 minus s cancel each other, and it will become 1 by 2 pi ns into I2 square R2 by s. So this is my constant term, so we can write it as k into I2 square R2 by s. Now this torque, again we have mentioned that this is basically the combination of two torque, Tf, which is my k into I2 square R2 divided by s, and Tb, which is my k into I2 square R2 by 2 minus s with a minus sign, and this is in Newton. The unit is Newton, right? So now if we convert this into synchronous watt. Now if we convert this into synchronous watt, what is my synchronous watt? Now synchronous watt is defined as the torque. Synchronous was defined as the torque developed by the motor, such as the power input to the rotor across the air gap is 1 watt. So that is the torque developed by the motor for a development of power of 1 watt, right? So the torque produced in a induction motor given as torque equals to, what is my torque? I have just mentioned P by omega, that is equals to that is equals to P by 2 pi n, where n is rpm, so that is equals to P by 2 pi n by 2 pi n by 60, right? So that is equals to 60 p by 2 n, 60 p by 2 n, right? So now we know from here that 1 synchronous watt equals to this 60 p by 2 n Newton meter. So in 60 p by 2 Newton meter, that means 1 Newton meter equals to 2 pi, sorry, 1 pi is here, I have forgotten, 2 pi, 1 Newton meter equals to 2 pi n by 60 synchronous watt, 2 pi n by 60 synchronous watt. So what I have deduced just few minutes back, that TF equals to k into I2 square R2 by S, right? So where this k is that 2 pi f term, that is that k equals to 1 by 2 pi ns, k equals to 1 by 2 pi ns, right? So this is in Newton meter. So in synchronous watt it will be only I2 square by R2 by S synchronous watt, right? Because we have seen just few minutes back that 1 synchronous watt equals to this 1 by 2 pi ns, that is ns equals to if ns equals to rpm, that is ns equals to 60 rps. So 60 by 2 pi ns, 60 by 2 pi ns. So 1 synchronous watt equals to 60 by 2 pi ns Newton meter. 1 synchronous watt equals to this Newton meter. So I have omit this k value and I am changing the dimension to synchronous watt. Similarly for TB, it will become it is minus k I2 square R2 by 2 minus S. So again it is in Newton meter. So it will become I2 square R2 by 2 minus S in synchronous watt, right? And we know that the total resultant torque T equals to nothing but this TF plus TB, right? Okay, and TB is minus, we can mention it also TF minus TB also, both are same thing. Now that if we see that our torque characteristics, so from here we can see the total range is from 0 to 2. The range is from 0 to 2, right? This is the slip range 0 to 2. So if S equals to 1 at standstill, S equals to 1. So what is my 2 minus S? It is also 1. So this 2 minus S is also 1, this S is also 1. So TF is becoming I2 square R2 and TB is becoming I2 square minus I2 square R2. So the total torque is 0. So as this is 0, which we have proved from double revolving theory, so the single phase induction motor is not self-static motor. But if we give initial thrust in any direction, suppose we have given an initial thrust to the rotor in the clockwise direction, that among these two torque, one torque will become predominant to the other and some positive torque we will get in the clockwise direction, which will make the rotor to start rotate. So for that reason we have mentioned, when we have discussed the working principle of single phase induction motor, a capacitor C is used in addition to a centrifugal switch to make the single phase induction motor self-starting motor, and this capacitor is connected with starting winding or auxiliary winding, and when the motors got its initial inertia to start, this centrifugal switch cut this winding, starting winding, rather the capacitor from the circuit, and the motor will automatically start rotating. So in this fashion the single phase motor can be constructed as self-starting motor. So in my next class we will develop the equivalent circuit of the single phase induction motor with the help of double revolving field theory, and we will also discuss that how this initial thrust can be given to the rotor, that different method to start the single phase induction motor. Okay, thank you.